Okay, now we're going to take a look at examples of the drinks problems from the menu project. So this is one example. The population of Tink Town can be modeled by the function f of x is equal to 5,000 times 1.35 to the x power, where x represents the time since the population has increased, and f of x represents the population after x amount of years. What is the rate of growth for this population? Now, before we do these problems, we want to remember that there was two types of equations that we dealt with, or actually three. First, we'll talk about the standard form, which is the function of x. Oh, what did I do? There we go. The function of x is equal to ab to the x power. This is the standard form of exponential functions. Now we have two other types, and this is for exponential growth. I'll write EG. This is the function of x is equal to a, and instead of b, we have this bigger value, which is 1 plus r, which stands for our rate, to the x power. Or sometimes you might see to the t power. And then for exponential decay, let's say ED, we have the function of x is equal to, it's almost the exact same thing, a times 1. The only difference is that we have a minus r to the x power. Now, we see here that the function that represents, so the function can be modeled by the function of x is equal to 5,000 times 1.35 to the x power, where x represents time, and the function of x represents the population after x amount of years. Okay, there we go. So let's take a look at this, and we have the function of x is equal to 5,000 times 1.35 to the x power. And some things that we wanted to remember is that a represents our initial value, r represents our rate. Now, this is very important, our rate as a decimal. And x represents time. So if we look at this equation, something that they're asking us is, what is the rate of growth for the population? Now, if we look at the exponential growth function, we'll notice that the rate of growth is 1 plus r. So if we look at our b value, or the value inside the parentheses, we notice that this is 1.35. So we can see that this here is 1 plus whatever value this was equal to 1.35. And if we know that, we can see that this is 0.35. Now, this is our rate as a decimal. So the question is, what is the rate of growth for this population? So this is 0.35, but if we wanted to convert this to a percent, you can just multiply it by 100. So I'll show you really quickly right here. So 0.35 times 100 is equal to 35. So this here is 35%. So we want to type an explanation. The rate of growth of the population is 35%. Okay, so that was an example of an exponential growth problem. We're going to move on to an exponential decay problem. Juanico buys a brand new car. The car's value depreciates after each year. The value of the car can be represented by the function c of t is equal to 35,000 times 0.88t, where c of t represents the value of the car after t amount of years. Which value represents the rate of decay for the car's value? Okay, so before we get started, I want to come back to these equations that we had here, and I'll bring this over to the next slide. Oh, it didn't work. 1 second. And it's right here. Okay, so here we have our standard form, our exponential growth, and our exponential decay. So in this example, the function is c of t is equal to 35,000 times 0.88 to the t power. Now reading this, I see that c of t represents the value of the car, and t represents the amount of years. So let's take a look which value represents the rate of decay. So something I want to emphasize here is that they're talking about decay this time. So we're going to look at the exponential decay formula. So remember, a is our initial value. So our initial value is that first number there that's being multiplied. That there is 35,000. So what this means is that the car, when she bought it, when Juanico bought it, it cost 35,000. Okay. Now we have 1 minus r. So we're trying to figure out the rate, and since it's decay, we're looking at 1 minus r. So this is saying 1 minus r is equal to what's in this parentheses right here, 0.88. And then we have, instead of x, we have t, which is our time. Okay, so we're trying to figure out what's the rate of decay. So since this one's 0.88, if you notice here, this is not 1 plus r. This is 1 minus r. So 1 minus some value is equal to 0.88. The question is, what is that value? All right, we just want to fill in the blank there. So what we can do is we take 1, we subtract, since we know that we have to subtract some value to get 0.88. 1 minus 0.88 that right there is 0.12. Now we want to figure out what is the rate of decay. So if you notice, all of our answers are in percentage. So if our rate is 0.12, in order to turn it back into a percent, what do we have to do? We multiply your value by 100. And that gives you 12%. So the rate of decay is 12%.